All right. Okay. So last time we discussed the vector equation of a plane. So how do we obtain vector equation? For that, you need two vectors lie in the plane and a point on the plane. So you need two vectors lie in the plane with the point on the plane. Then you are able to find the vector equation. How? So from these two vectors, you can find the normal vector by taking the cross product, right? B cross C, which is normal to this plane, yeah. So that's why you need two vectors. So give me a second. I don't know whether. Yep. So that's we want to find the normal or perpendicular vector to the plane. That's why we need two vectors on the plane, lie in the plane, right? So B, C. So in other words, you can say this is the plane of B and C, right? Vector B and C, right? Yeah. So taking the cross product, yeah, you can find the B cross, which is perpendicular up, upside or downside, yeah, downwards. Yeah. So, all right. So here this is upward, yeah, pointing up, popping up. All right, so you need another point on the plane, then you are able to find the equation, take a variable point. So this is given. Take a variable r is a variable point on the plane, it varies. Yeah, you can, so r is a variable on the plane. So r takes x, y, z, right? Coordinates, because it is a variable on the plane. So x comma y comma z r. So then you know this vector, you can find r a vector which is perpendicular to this normal vector and take the dot product, which is 0. Yeah. Then we can obtain something in terms we can express we can express in terms of x, y, and z, which is called the vector equation. You can convert that into Cartesian if you like, right? Okay, right. So it is enough to find the normal vector, perpendicular vector to the plane, right? So if you are smart, you better find the normal vector, right? Better find the normal vector by dividing its magnitude. So you can reduce the computational cost, right? Finding the normal vector which is perpendicular, or normal which is perpendicular to plane. So if you are a smart person, that's why, yep. So you can reduce computation time, yeah, computational time by finding normal vector. Very easy. Just divide by its magnitude. That's all, right? Okay. You scale this one. You scale this B cross C by this. Yeah. Yes. So we talked, if you have a point on the plane, this time you are given only a point, right? So you don't have 2 points, two vectors to find this normal vector. This time you are given only 1 point, no 2 points, no two vectors, right? So at that time, ready, you need normal like a radical. One guy is asking a question. Normal vector can the වැඩි කරන්නේ නැත්නම් unit normal එකෙන්ද වැඩි කරන්නේ ඔක්කොම එකයි මෙතන unit normal හරි normal vector එක මොකද theory එක මේකයි ලම්බකයි නේ dot product එක බිඳුව එච්චරයි මේක සුළු වෙලායි නිකන් unique normal එකෙන් වැඩි කරත් මෙතන නිකන් normal vector එක තිබ්බත් හරි ඒත් හැමතිස්සම unit එක හොයන්න computation ඔයාට සුළු කිරීම හරි ලේසි වෙනවා. ඒකයි. අර ඉස්සෙල්ලත් බලන්න ඉස්සෙල්ල question එක මම නේ. අර ඊමේල් එකේ මම හෙව්වේ ප්‍රොජෙක්ෂන් එක හොයාගෙන තියාගත්ත යුනික් normal යුනික් vector එක along කොයි පැත්තට ඒ පැත්තට ඒක හොයාගෙන තියාගන්න. එතකොට හරි ලේසි ඒකයි කියන්නේ වැඩේ. දෙකම හරි ඉතින්. මෙතන බිඳුව නිසා සුළු වෙයි. හරියටයි. හරි. කොහොමද දෙකම number මේ දෙක. හරි. All right. So this time you are given a point only on the plane. Point only. So no other vectors. So how do we find this guy, this unique normal vector or perpendicular vector to the plane? Yeah, you can do that. Yeah, so for that you need to find these directional cosines. Yep, last time we discussed how do we find the directional cosines. Yep, then we get the unit. Then we get the unit normal vector. So this vector is perpendicular to plane. Then you are able to find. So take the dot product. So because this one and this guy is perpendicular, dot product is 0. Right? Okay. All right. So like that you can find equation of the plane. Yeah, we discussed last time. Yep. And if you have two planes which are intersecting at a straight line like this, right? They are non-parallel, right? So how do you know which is not they are non-parallel? Yep, you can consider. So if you have a plane, like this, and let's say you have another plane, then you know normal vector, right? Or perpendicular vector. Let's say this is the equation of plane. Ax plus by plus cz equals some constant d is the Cartesian equation of this plane. Then as I said before, I will prove this later, a little later. Normal vector to this plane is if you like, you can write that form. I will write ABC vector. This vector is always perpendicular to this plane. That's right. So n1, n2. You could find if you are given equations of these two, you can find n1, n2 very easily. Those are coefficients of x, y, and z. You know these vectors, right? So by taking the cross product, you can check whether it is parallel or non-parallel. If the cross product of n1 and n2 is 0, they are parallel. If they are non-zero, then they are non-parallel planes. Then they they intersect at this straight line. This is common line to both planes. So and the other thing is cross product of n1 and n2 is parallel to this line. You have that information as well. Right? So cross product of this is parallel to this intersection line. Then you can find the equation of this intersection line if you want. Right? So in the exam, I will give maybe I will give you equation of this and equation of that. Then find the equation of the intersection line. Pretty simple. Okay, and this time a plane you are given a plane, so definitely you know the equation of this plane. That means you know the normal vector to this plane, right? It, it is known, right? And a point outside from this, from this plane. Then find the shortest distance between this plane and the point. So pretty simple. The shortest distance is the perpendicular distance. Yeah, perpendicular. If you drop a perpendicular to plane, the length of this line segment is the shortest distance. Yeah. Do hours actual marks. No, this is a practice. Yeah. So sometimes I will count. Yeah, I will take a couple of assignments to your final grade. Yeah, I will consider portion of your assignments. Yep. Assignment marks. Yep. So I don't consider all of them. Yep. Take a couple of, yep, maybe some of assignments. So that is good for you to get good grades at the exam. So from now on, you are practicing. Yep. So I don't know how you feel about this subject. Remember the first day? Yep. So I summarized everything, right? We started from A, B, C. So we distinguish between vector and scalar, right? And start develop small things. And now we are at the end of this session. Yeah, this is the last session. Then I will start another new session, vector field and scalar fields. Yep. Yeah, let me finish this off. Yeah, so then I will explain that today. So today I have to cover this entire PDF. Let me, yep, for that I need time. Yep, so let me finish this off. So let's try to understand. Yep, so how do we find the, shortest distance, length of, this is the shortest distance. Yep. So if you know the point, equation of the point, equation of the plane. Yep. Then you can find any point on the plane. Yeah, because you know the equation of the plane. Now you know this is given, right? Then you can find this vector very easily. And you know the equation because you know the equation. You know this perpendicular vector to the plane, right? Coefficients of x, y, and z. Yep. Makes sense? Yep. So you know this vector here, the perpendicular length is this guy times cosine of theta. Yeah. So here you get cosine. Cosine, dot product. I remember that product, take the dot product of these two vectors. Yeah. So you consider that product there, right? Earlier, remember earlier sine theta here. Now again cos theta projection. Yeah, projection cos theta. Yep. So this makes sense. All right, no problem with that. Okay. And yeah, so now, so this time you are given an equation of a plane, an equation of a straight line. And how do we find the intersection point? Yeah, pretty simple. You know, yep. So you know the equation of the straight line, and all you need to do is you have to find the correct parameter value. So you know this lambda, when you change this parameter lambda, it varies on the plane. You have to find this point here. Find the correct lambda. How do you find? Because this point, this point on the plane, that point satisfies the equation of this plane. That's all, right? And you get lambda, correct lambda. and put that lambda into the equation, then you get coordinates x component y z. Yeah, pretty simple. And the other one, if you intersection of three planes. Yep. So we know that you had to. You are given equation of three planes. Then you can find normal vectors. Yep. So right, normal. Plane to plane. Plane to plane. If they are parallel, someone is asking a question. How can we compute minimum distance from a plane to another plane? Yep. So it's we cannot ask that, because if it is point, you can ask the minimum distance, but plane to plane, no, right? You cannot define. If you have a point like this outside, so you can talk about the minimum distance, but plane to plane, a straight line to straight line, okay. Plane, if the planes are parallel, but you can find the distance between two planes by reducing the coefficient. Very easy. If they intersect, so how do you minimum distance? That does not make sense, I think, that question, right? If you have those kind of questions, you have to ask. Right. So so if you this time you are given the equation, you are given equations of three planes. That means you know these n1, n2, n3. You know how to find these n1, n2, n3, right? So you can check whether they are each of them are parallel or not. So take the cross product. If it is equal to zero vector, that says, these two planes are parallel to each other. But it is non-zero, then it is not parallel. So that means they intersect at a straight line like this. Right? Like that, you can check n1, n2, n1, n3, n2, n3. So then they are, so each of so if you take one, if you pick one, so this one is not parallel with this, and this one is not parallel with that, right? And here, and provided that here any one of planes is not parallel to line of intersection. So so then we can say those three planes cut. Those three planes cut at cut a single point in the space. But here, look at this figure. So each of them are non-parallel. Right, each of them are non-parallel. This one, non-parallel. Non-parallel. So if you look at the normal, so normal vector. So this is the common line. This is the common intersection line of these two planes, this one and this one. And look at this one here. So this third one. So normal vector, so normal to this plane is perpendicular to the line of intersection, right? Right. So when you take the dot product of this line, this vector with the normal vector of this third one, you get 0, right? You get 0 in this case. So this is called, you remember this is a scalar triple product. If the scalar triple product is not equal to 0, that means you are able to find this single point. That means this system has a unique solution. Otherwise, this system does not have solutions. Right? Does not have solutions. Sometimes, so if you draw like this, let's say, yep. So your planes. So there's one of planes, another plane, another third one is this. You cannot see that. Going down. Yeah. So here you can find, so this line is common to all three planes, alpha, beta, gamma. So the line of intersection is common to alpha, beta, gamma. So for this system, there are infinitely many solutions to this system, because you could find infinitely many points that are common to all three planes. Okay. If you can, so sometimes it is able to, so in this case, what is the scalar triple product? This one, and this one, parallel, Okay, what happened to scalar triple product? So when you take the cross product of this guy and this guy, so which is parallel to this line of intersection, right? That lies on this third plane. When you take the dot product of this one and this, you get 0. Okay, right. So if this is non-zero, you can say this system has unique solution, not infinitely many. Unique solution, a particular point. Got it? Does that make sense? So if this scalar triple product of these norms, n1, n2, n3, is non-zero, then you can say, this system has a unique solution. Only one. You can find only one point, not more than. Got it? So this is the important remark of this. Does that make sense? Yep. It's time to ask questions.